Heterogeneous equilibrium is when reactants and products are in different phases. And if that's the case, then we do not include concentration of pure solids and pure liquids in equilibrium constant. Why? Because we assume their concentration does not change, and also it's integrated within equilibrium constant. I'll give you a couple of examples. For example, if you take a limestone, which is calcium carbonate, a solid, and if you heat it up, eventually it becomes calcium oxide and it releases carbon dioxide, a gas. If it's in a closed flask, there is equilibrium. Now, when we ask you to write equilibrium expression or constant, you write K equilibrium, which is products over reactants, but we are not going to include calcium oxide, a solid, and calcium carbonate. So it's simply concentration of carbon dioxide. This is what dictates your equilibrium constant. Another example is example of organic acids. So if I give you ethanoic acid, CH3COOH, aqueous, if it touches moisture, liquid water, it will dissociate into hydronium ion, aqueous, plus the anion of this acid, which is CH3COO minus aqueous. Now there is equilibrium. And if we ask you to write equilibrium expression, this is K equilibrium. Since this is an acid, we can also write it K subscript A for acid. It's products over reactants. Products are aqueous, I write it. Reactants, however, one of them is liquid, and I'm not going to include it, which is water. I only include ethanoic acid in the denominator. Another related example is dissociation of weak acids, for example, ammonia. Then again, when it touches moisture, liquid water, it dissociates partially, which is another name for equilibrium, to give you ammonium, NH4 plus aqueous, and hydroxide ion, which is an indicator of a base, aqueous. If we ask you to write equilibrium expression, we can write it as K subscript B because it's a base. It's simply products over reactants, but do not include water because it's pure liquid. So for heterogeneous equations, do not include pure liquids and pure solids in your equilibrium expressions.